Hello everyone, and welcome back to Lesson 3, Neural Networks. In this video, we're going to be talking all about convolutional neural networks, which is a specific category in this field, and we're going to take a look at why they're so unique and how they work. So let's get right into it. First up, convolutional neural networks, often abbreviated as CNNs, are a class of artificial neural networks that have a structure based on several layers called convolutions. We use them in many applications, including recommender systems, brain-image interface, medical imaging analysis, image segmentation, video recognition, and much, much more. But how do they do all of this in the first place? Well, CNNs are inspired by the organization of neurons in the animal visual cortex, which is the part of the brain that helps us to process the information that comes from our eyes. So let's understand how it works. First, we have a convolution, which is a mathematical operation that lets us find a pattern in an image section. And it does so by applying a kernel, which is the mathematical representation of pixels of the pattern that we are searching for. And a convolutional layer is the neural network layer that searches the entirety of an image for a pattern by applying said convolutions. So let's see how these convolutions work. So here, let's say that we have a 3x3 matrix, and then we also have a kernel, which is a 2x2 matrix. And of course, when you're looking at a real-life scenario, your image will have many, many more pixels, but this is just for simplicity's sake. So what we're going to do is we're going to multiply the kernel by different tiles of our original matrix and see what that gets us. So for example, here we have this little yellow box that I'm going to move around to represent when we're applying the kernel. So first up, we're going to apply the kernel to this tile of 2x2 right here. So when we apply the kernel, we're going to multiply each corresponding factor. So here, right, we see that 2 is the upper left corner of this section of the matrix, and it's also the upper left corner of the kernel. So we're going to do 2 times 1. Similarly, we're going to do 0 times 0, 1 times 0, and 2 times 1. And then we're going to add all of that up. So we get the sum of that is 4. And so then we're going to put it in the upper left box of our resulting matrix. And then we're going to apply the kernel here. And so now we're going to do 0 times 1 plus 1 times 0 plus 2 times 0 plus 0 times 1, which all adds up to 0. Next up, we're going to apply the kernel to this section. So we're going to do 1 times 1 plus 2 times 0 plus 0 times 0 plus 1 times 0. And when we add all of that up, we get 2. And finally, we're going to apply it to this section right here. So we're going to do 2 times 1 plus 0 times 0 plus 1 times 0 plus 2 times 1, which again ends up being 4. And so when we do all of that, we finally get this resulting matrix right here. And so as we apply different kernels, we can check for different functions. So different kernels can do things like blurring, sharpening, edge detection, embossing, and more. And so as we pass it through several convolutional layers, we process the image in different ways to make it easier to detect certain features. Then we have the pooling layer, which processes our final image, and it does so by taking the maximum of different sections of a resulting matrix. So basically, we're going to try to make the final image smaller, so that a smaller matrix is easier to process and recognize. So let's take a look here. So we're going to have this 4x4 matrix as an example, and then we're going to apply our pooling layer to reduce it to this 2x2 matrix. So I'm just going to use these yellow boxes and move them around to highlight it as we perform this operation. So first, let's take a look at this upper left-hand corner. We have the numbers 8, 3, -11, and 16. The largest number of all of that is 16, which is why we're going to pop it in this spot right here. Now let's do that with the other sections. So when we move it here, we see that the biggest number in this section is 31, so we're going to place 31 right here. Then in this section, we see that the biggest number is 21. So we're going to put 21 right here. And finally, in this last section, we see that the biggest number is 9. So we're going to place 9 right here. And that's how the pooling layer processes it. So as you can see, we've reduced this matrix so that it's easier to explain and understand for this next section. And that brings us to our fully connected layer. The fully connected layer is a layer where each neuron is connected to every other neuron. So I've drawn a simple diagram here where we have 4 neurons connected to 3 neurons in the next step. And as you can see, every single neuron on each side has a connection. And now we can finally put it all together. So let's check it out. First, we have our input. Then we're going to pass it through several convolutional layers that apply kernels and use convolutions to process the image. Then we're going to pass it through a pooling layer that will simplify our image and make it easier to process. And finally, we're going to put it through our fully connected layer, which is going to analyze the image and pull out its key features. And then that brings us to the output, which will in some way be detected or labeled by the computer, showing that it understood what's going on. Okay, so let's go ahead and summarize this lesson. So CNNs are a type of neural network comprised of many layers, specifically convolutional, pooling, and fully connected layers. A convolutional layer applies kernels to do convolutions, and these convolutions will help to process our image and look for specific sections and enhance it further. Then a pooling layer will basically reduce the size of the matrix that represents the image, making it easier to process. And finally, a fully connected layer will actually analyze this image matrix and go ahead and pull out the key features that we were looking for in the first place. And so this makes CNNs great for processing many types of visual input. And again, they were modeled after the animal visual cortex. So this is exactly the type of work that they were designed for. Okay, I think that wraps up today's video. Thank you so much for watching. I know we definitely covered a lot of content, and I hope that it made sense and that you learned something new. And if you're interested in learning more, you can go ahead and check out our next video on another type of neural network called graph neural networks, and I'm excited to see you there. Okay, bye!